In this video lecture, we're going to be covering negative angles as well as the section on cofunctions. So let's begin with our Cartesian plane, and I want you to recall the cast diagram. So remember, in your Cartesian plane, we have that it's divided into 4 quadrants. This is quadrant 1, 2, 3, and 4. Remember that in the previous lecture, we discussed the cast diagram, C-A-S-T, and essentially what this diagram tells you is that in the first quadrant all trig ratios are positive. In the second quadrant only sine, the ratios for sine are positive. In the third quadrant only tan is positive, and in the fourth only cos. Right, so we had studied this, and thereafter we looked at reduction of angles, but up until that point we only discussed positive angles, meaning all of those angles which moved or were obtained moving in the counterclockwise direction. What happens if we move in the clockwise direction? So as before, we still have our 4 quadrants and we could still talk about our degrees. So observe that the angle negative theta is in the 4th quadrant, theta minus 180 is in the 3rd quadrant, minus theta minus 180 is in the 2nd quadrant, and we have theta minus 360 degrees in the 1st quadrant. Right, so we now need to marry whatever is in this diagram with the cast diagram in order to write down what the trig ratios would be. So let's assess each and every one. Let's start off with negative theta. Right, so we want to find out what is sine of negative theta, cos of negative theta, and tan of negative theta. Again, this is using your reduction as well as your cast diagram. So observe, in the 4th quadrant only cos is positive. So as a result, cos of minus theta will be equal to positive cos theta. But for the other 2, it will result in negative answers. So this becomes negative sine theta, and tan of negative theta becomes negative tan theta. Let's now look at theta minus 360. Right, so if I had to take sine of theta minus 360, cos of theta minus 360 degrees, and tan of theta minus 360 degrees, and observe theta minus 360 is in the 1st quadrant. In that quadrant all ratios are positive, so we know that we are going to get back positive answers. So this is sine theta, this is cos theta, and this is tan theta. But observe that whether this was theta minus 360 or theta plus 360, we would have gotten back the same answers. Right, so this was also covered with you previously. Right, so then we've got the other 2 quadrants to deal with. So let me now deal with negative theta minus 180. Right, so I can just rewrite that as minus 180 minus theta instead. So it's fine to rewrite by swapping. So this becomes sine of negative 180 minus theta. This is the same as saying minus theta minus 180 degrees. Cos of minus 180 minus theta, and tan of minus 180 minus theta. Right, so we're in the 2nd quadrant, and we know that only sine is positive. So we then have that this is equal to sine theta. This will then be equal to negative cos theta, and tan of 180 minus theta is going to be equal to negative tan theta. Repeating this for the 3rd quadrant, we're now going to compute sine of theta minus 180. I can rewrite that as minus 180 plus theta, cos of minus 180 plus theta, and tan of minus 180 plus theta. Again, we need to reconcile this with the cast diagram. In the 3rd quadrant, only tan is positive, so we know that tan of minus 180 plus theta will give us back positive tan theta, And for the other two ratios, we have negative sine theta, and cos of 180 plus theta is negative cos theta. So it's important to remember the negative angles in each quadrant and the cast diagram. So instead of memorizing these formulae, if you just remember these two diagrams, you will be able to write down any of the formulae that I had reproduced. Right, so that discusses the section on negative angles. And the next thing that I want to discuss is co-functions. Right, so to discuss co-functions, I have drawn a right angle triangle where the lengths of the sides are given by length A, B, and C, and I've drawn a reference angle of theta in this right angled triangle. So if we have 90 degrees and theta degrees in this triangle, and I wanted to compute what is this angle equal to, then of course 180 minus 90 minus theta gives you an answer of 90 minus theta. So this angle is 90 minus theta degrees. Keeping that in mind, we can now discuss the ratios associated with theta and 90 minus theta. So let's do some computation. Let's find out what is sine of theta. Remember your acronym SO CARTOA? Right, so if you've forgotten it, this always comes to your aid. Sine is opposite over hypotenuse. We're working with reference angle theta. Opposite over hypotenuse is B over A. Let's now compute cos of 90 minus theta. Right, so 90 minus theta is that reference angle. Cos is adjacent over hypotenuse. So this is the reference angle. What is the adjacent? It's B, and the hypotenuse is A. So it's B over A. So observe that we have sine of theta and cos of 90 minus theta both equal to B over A. So these two ratios are equal. So essentially we have that sine theta is equal to cos of 90 minus theta. Right, let's observe something else. Let's now take cos of theta. Right, so here's our reference angle. Cos is adjacent over hypotenuse. So adjacent is C over hypotenuse is A. So cos of theta is C over A. Let's now compute sine of 90 minus theta. So 90 minus theta is the reference angle. That's what we are working with. Sine is opposite over hypotenuse. For 90 minus theta, C is opposite, the length that you require, and the hypotenuse is A. So this is C over A. So once again, we've got observe that cos of theta is equal to sine of 90 minus theta, which is C over A. So these two things are equal, and we summarize that cos theta equals sine of 90 minus theta. So essentially what's happened here is we've got these ratios where cos and sine are written in terms of one another. Right, and trig ratios of angles that add up to 90 degrees are called co-functions. Right, so in summary, I'm going to write down some formulae for you. Right, but essentially what it does is it gives you sine in terms of cos or cos in terms of sine. So we have that sine of 90 minus theta is equal to cos of theta. And observe that 90 minus theta is in the first quadrant. Right, so we know that all trig ratios are positive in there. So sine is positive, so we will have a positive answer. Cos of 90 minus theta is sine of theta. And again, since 90 minus theta is in the first quadrant, we know that cos is positive, so we've got a resultant positive answer. Let's now take sine of 90 plus theta. Right, so 90 plus theta is in the second quadrant. In the second quadrant, we know that by the cast diagram that only sine is positive. So that means we will get back a positive answer, but since this is a co-function, it's cos of theta. Right, and finally, let's discuss cos of 90 plus theta. Again, same reasoning, we are in the second quadrant, only sine is positive, so we get back a negative answer. And since this is a co-function, it's negative sine of theta. So again, important formulae for you to know. Right, so now that we understand negative angles and co-functions, let's now look at some examples. So let's answer the following. Right, so here we have two expressions that need to be simplified. Let's consider the first one. So this is going to be a combination of reduction that you've learned before, as well as what we have just gone through. Right, so looking at the first one, we've got 2 times sine of 180 minus x. Right, so remember 180 minus x is in the second quadrant, so therefore by reduction this is just sine of x, so it's 2 times sine of x. 360 minus x, that is in your fourth quadrant, cos is positive, so this gives us back cos of x, right? And looking at the denominator, cos of 90 minus x, we know that this is a co-function, and this is in the first quadrant, so this is just positive sine x. Cos of 180 minus x, this is in the second quadrant. By reduction, we know this is going to give us a negative answer. So we get back negative cos x. We now can simplify. Observe that sine of x cancels, cos of x also cancels, but we have a negative in the denominator, so we've got 2 divided by minus 1, which is negative 2. Let's look at the next question. Right, so looking at this, remember these are being multiplied and then added to cos of 90 plus x. So let's simplify in the numerator. Tan of 180 minus x, second quadrant, and in the second quadrant only sine is positive, so I know I'm going to get back a negative answer here, so this is minus tan x. I'm multiplying to cos of 360 minus x. This is in the fourth quadrant, only cos is positive, so this is cos of x. Right, they're being multiplied, and now I'm adding. This is a co-function. 90 plus x lies in the second quadrant, and only sine is positive, so I know it's minus sine x. Right, so important to keep track of all of the signs, so therefore I've bracketed that out. Remember, it's still being added at the end. Cos of 90 minus x, that's a co-function from the first quadrant, so this is sine x. We've been multiplying to sine of 90 plus x. 90 plus x, second quadrant, but sine is positive in the second quadrant, so this is cos of x. Let's now simplify everything that we have. Remember that tan of x can be expressed as sine x divided by cos of x. Right, so I'm just rewriting my numerator. Right, so we've got positive and a negative, so if I want to, I could just write that as minus sine x. Right, and then here sine x in the denominator times cos x. Simplifying now, I've got this bracket being multiplied to cos x. That cancels, so I'm left with minus sine x in the numerator minus sine x, right? Divided by sine x times cos x. So minus sine x is minus 2 sine x. And again, this is being divided by sine x times cos x. So now we can simplify. Right, so we observe that sine x cancel. I'm left with negative 2 in the numerator divided by cos of x. And that's the final answer. Right, and that's where I'm ending.